When people imagine teleportation, they picture something almost magical. You step into a chamber, there's a flash of light, maybe a hum of energy, and then suddenly you're standing on Mars or in Tokyo. It feels like travel without movement. But here's the first thing we have to understand, and this is not philosophy. This is physics. You are not a solid object that can simply be moved like a suitcase from one coordinate to another. You feel solid. You look solid. But at the microscopic level, you are a constantly changing arrangement of atoms, exchanging particles with the air, the food you eat, the ground beneath your feet. The atoms in your body today are not the same atoms you had years ago. In fact, many of them weren't even in your body a few months ago. What persists is not the material itself, it's the pattern. Now that sounds comforting at first. Ah, you might say, so if teleportation preserves the pattern, then it preserves me. But slow down, because a pattern is not a thing. A pattern is a process, it's something happening, and processes are not objects you can freeze and pick up. They are ongoing activities. Think about a flame. A flame looks like a stable object. You can point at it. But it isn't a thing in the way a rock is a thing. It's a continuous chemical reaction. If you blow it out and reignite another flame somewhere else with the same shape, the same color, even the same temperature, is it the same flame? It looks identical, but the original process ended. A new one began. You are far more complex than a flame, but in principle the same logic applies. Your brain is not a static sculpture of neurons. It is electrical activity flowing through networks, chemical gradients shifting across synapses, ions moving in delicate balance. At any moment, your thoughts, your memories, your sense of self are encoded in dynamic activity, patterns of firing neurons that are unfolding in time. So, what would teleportation actually require? Not just a photograph of your body, not just a rough scan. It would require mapping the exact position and momentum of every particle, the exact electrical state of every neuron, the exact configuration of every molecular bond. That's an astronomical amount of information, and to capture that information with perfect precision, you cannot leave the original intact. You must measure it completely, and at that level measurement is not passive, it is invasive. To scan you perfectly is to dismantle you. The machine would not move you. It would reduce you to data, an abstract description of your structure, and then use raw materials at the destination to reconstruct that structure. Atom by atom, molecule by molecule, neuron by neuron. But here's the uncomfortable part. The original physical process, the one happening in your brain right now, would stop. Your heart would not gradually slow as in natural death. There would be no dramatic moment. There would simply be a disassembly. The continuity of the process that you experience as I would end, and somewhere else a new process would begin. Identical memories, identical personality, identical scars and habits and fears. That person would wake up believing they are you. They would remember stepping into the machine. They would feel continuous, but the continuity would be an illusion created by memory. Physics does not track identity. It tracks states. If one state transitions smoothly into another, we call it continuity. But teleportation is not a smooth transition. It is destruction followed by reconstruction. There is a break in the chain. And you might say, well, if the copy feels like me, acts like me, thinks like me, then practically speaking, what's the difference? The difference is subtle but profound. From the outside, none. From the inside, everything, because what you are, at the most fundamental level, is not your structure. It is the uninterrupted flow of experience generated by that structure. It is the ongoing activity. And once that activity stops, even for an instant, the subjective thread is cut. teleportation doesn't carry the thread across space. It ties a new thread somewhere else that looks exactly the same. That is why the illusion of continuity is so seductive. We mistake structural similarity for personal survival. We confuse replication with persistence. But physics forces us to confront a stark possibility. You are not a thing that can be moved. You are a process that can only continue or end, and if teleportation works by ending the process in one place and restarting it in another, then the question isn't whether it transports you. The question is whether you're willing to step into a machine that replaces you. Now, once you begin to see yourself as a process rather than a thing, the next problem becomes even more unsettling. Because even if we were comfortable with the idea of disassembly and reconstruction, physics itself places a deeper restriction on what can actually be known, copied, or transmitted. And this isn't philosophical hesitation. This comes straight out of quantum mechanics. At the microscopic level, the universe does not behave like a collection of tiny billiard balls. Every particle, every electron in your brain, every proton in your DNA, exists in what we call a quantum state. That state is not just a position in space. It includes probabilities, phases, subtle relational properties that only make sense within the mathematics of wave functions. And here is the critical point. There is a fundamental rule in quantum theory called the No-Cloning Theorem. It tells us something precise and unavoidable. You cannot create an exact copy of an unknown quantum state. Not because we lack technology, not because we haven't figured it out yet, but because the structure of quantum mechanics forbids it. To duplicate a classical object, say, a printed page, you measure it and reproduce it. But quantum information does not behave that way. The act of measuring a quantum system changes it. You cannot look at an electron's full state without disturbing the very thing you're trying to preserve. The measurement collapses possibilities into one outcome. Now imagine what teleportation would require. You would need to capture the complete quantum state of roughly 10 particles that make up a human body. Not an approximation, not a rough blueprint, a perfect description. Because if even tiny details in the brain's quantum configuration differ, the resulting neural dynamics could diverge. But the moment you try to extract that complete state, you destroy the original configuration. You don't gently scan it like a barcode. You force it into definite values. The delicate superpositions that were there gone. The correlations altered. In other words, to read the book perfectly, you must burn the pages as you scan them. Some people respond, well, quantum teleportation already exists. And that's true in a very narrow and precise sense. Experiments have demonstrated quantum state trance for using entanglement. But notice what actually happens in those experiments. The original state is destroyed in the process. And what's transmitted is not matter, but information encoded via entangled particles. Even in the best case quantum teleportation protocol, there is no duplication. There is a transfer that requires the original to cease being in that state. Scale that up to a human being, and the implications become stark. If teleportation were to work in a way consistent with quantum mechanics, the original quantum state that constitutes your living brain must be irreversibly altered. There is no way to preserve it and copy it simultaneously. The universe does not allow perfect twins at the quantum level. And here's where it becomes psychologically uncomfortable, because when we imagine teleportation, we quietly assume that the original could, at least in principle, remain intact while a copy is made somewhere else. That's the comforting fantasy. Step into the chamber and somewhere else you appear. But quantum mechanics says no. If the copy is exact, the original must be gone. If the original remains, the copy cannot be exact. There is no loophole hiding in future technology. This is not an engineering problem waiting for smarter engineers. It is written into the mathematics of Hilbert spaces and linear operators. The impossibility is structural. So now the narrative shifts. Teleportation is not merely reconstruction after destruction, as we discussed earlier. It is forced destruction at the deepest physical level in order to extract transferable information. The act of knowing the system completely annihilates its prior state. You might say, but if the reconstructed version behaves exactly like me, remembers my childhood, loves the same people, fears the same things, what have I really lost? You have lost the only thing that was ever uniquely yours, the uninterrupted quantum evolution of your particular physical process. From the outside, the difference is invisible. From the inside, it is absolute. Quantum theory doesn't care about your memories. It cares about amplitudes and states, and it tells us that identity cannot be photocopied without cost. The cost is the original configuration of reality that is you. So teleportation, if it respects physics, cannot be gentle. It cannot be reversible. It cannot quietly make a backup while you watch. It must collapse you into data and extinguish the precise state that is currently generating your awareness. And that leads to a chilling realization. The machine doesn't malfunction when it destroys you. It is functioning exactly as physics requires. The universe is not cruel about this. It is simply consistent. And when you understand that the laws of quantum mechanics forbid perfect copying without annihilation, you begin to see teleportation for what it truly is, not a bridge through space, but a final measurement. Before you ever step into such a machine, you must ask yourself a harder question than will it work. You must ask, am I willing to be the price that physics demands? Now let's suppose, just for the sake of argument, that we solve the engineering. Suppose we accept the destruction required by quantum mechanics. Suppose the machine measures everything it must measure, transmits the information, reconstructs every atom in exactly the right configuration. No errors, no noise, perfect fidelity. You step into the chamber in New York. A moment later, someone steps out in Tokyo. That person remembers your childhood. They remember their first fear, their first love, the way their mother laughed, the insecurity they never admitted to anyone. They know the password to your email. They feel continuous. They insist they are you. From every external test, they are indistinguishable from you. So here's the question that cuts deeper than physics. Is identity just information? It's tempting to say yes. After all, what are you if not your memories, your personality, your patterns of thought? If those are preserved perfectly, hasn't everything that matters survived? But slow down and look carefully at what is happening. Imagine, instead of destroying the original, the machine glitches and leaves the first version intact. Now there are two of you. Both share the same past. Both claim to be the real one. Both feel authentic. From that moment forward, their experiences diverge. One has coffee in Tokyo. The other walks out of the lab in New York, confused and furious. Which one is you? The question sounds absurd, but that's precisely the point. Identity cannot simply be information, because the same information can exist in two places at once. Information can branch. Experience cannot. You do not experience your twins' thoughts. You do not feel their hunger or see through their eyes. Your awareness, the thing you call I, is tied to a single physical process unfolding in one particular location. So, when teleportation destroys the original and creates a copy elsewhere, what has really happened? From the outside, the world continues smoothly. Your friends see you. Society continues interacting with you. But from the inside, From the perspective that actually matters, there has been a discontinuity. The stream of consciousness that was occurring in the original brain has ended. A new stream begins in the reconstructed brain. The new one contains memories of continuity, but memory is not the same thing as continuation. This distinction is subtle, but it is everything. Consider sleep. When you fall asleep, your brain does not stop. Activity changes, patterns shift, but the underlying biological process continues uninterrupted. That's why waking up feels continuous. The thread was never cut. Death is different. When the process stops entirely, when neural activity irreversibly ceases, the subjective stream ends. Even if someone later built an exact replica of your brain using the same blueprint, that new process would not resurrect the original awareness. It would initiate a new one that merely believes it is continuous. Teleportation, as we've described it, fits the second category. And this is where the psychological comfort begins to unravel. We assume that survival is about narrative. As long as the story continues, as long as the character persists in memory, we feel safe. But physics doesn't preserve narratives. It preserves structures and state transitions. Consciousness, whatever else it may be, appears to depend on ongoing physical dynamics. It is not stored like a file on a hard drive. It is enacted moment by electrochemical activity in living tissue. When that activity halts, even for an instant, in the absolute sense of termination, the enactment stops. There is no bridge carrying the subjective point of view across the gap. The copy in Tokyo does not inherit your awareness. It inherits your data. And here's the unsettling thought. The copy will never know the difference. It will feel authentic. It will argue passionately that teleportation works. It will laugh at the philosophical worry. It will say, "I'm standing here, aren't I?" Yes. It is standing there, but you are not. Teleportation doesn't fail because the machine breaks. It fails at the level of identity. It confuses duplication with survival. And maybe that forces us to confront something even larger. We often reduce ourselves to descriptions, personality profiles, brain scans, genetic codes. We talk as though if the pattern survives, we survive. But perhaps what truly matters is not the pattern alone, but the uninterrupted unfolding of that pattern in time. So, before we chase technologies that promise escape from distance, maybe we should ask a more intimate question. What does it actually mean to continue existing? Because if survival is not about being copied, but about not being interrupted, then teleportation doesn't extend your life. It ends it and sends a convincing replacement in your place. And the real challenge is not whether the copy believes it's you. The real challenge is whether you're willing to disappear so that something else can carry your name. And now we arrive at the most uncomfortable part of all, not the physics, not the equations, not the quantum theorems, but the psychology, because even after understanding everything we've discussed, most people still feel that teleportation is harmless. They shrug and say, if the copy thinks it's me, then for all practical purposes it is me. That reaction is revealing. It tells us something profound about how the human mind protects itself. Teleportation feels safe because it preserves what we can observe. Your face, your voice, your memories, your personality all intact. To your friends and family, nothing changes. Society continues as if nothing happened. The narrative flows forward seamlessly, and we are creatures who think in stories. If the story continues, we assume the character survives. But physics does not operate on narrative logic. It operates on state transitions, and the transition from original to copy is not gentle. It is not like walking through a doorway. It is not like stepping across a bridge. It is more like turning off one system and booting up another identical system elsewhere. Imagine two computers running the exact same program. You unplug one and power on the other. From the outside, the display looks continuous. The file is still open. The cursor is still blinking in the same place, but the electrical process in the first machine has stopped. A different physical process has begun in the second. We accept this easily with machines because we do not attribute subjective experience to them. But with ourselves, we instinctively resist the analogy. We feel like there must be something more, something that carries over. Yet all available evidence suggests that what we call the self is generated by physical activity. There is no observable mechanism that transfers awareness independently of matter. When the neural activity stops permanently, the experience stops permanently. Teleportation, as we've described it, requires precisely that stopping. The psychological horror lies in the gap between appearance and reality. From the outside, nothing tragic happens. No funeral, no mourning. The you that steps out smiles and waves. They reassure everyone. It worked, and everyone believes it. But if what matters is the uninterrupted continuity of awareness, then something irreversible occurred inside that chamber. A process that had been running since your earliest memory was terminated. And here's the most unsettling twist. The copy will defend the machine. The reconstructed version will passionately argue that teleportation is safe. After all, it remembers choosing to step in. It remembers the anticipation, the fear, the reasoning. It feels continuous. It has no access to the discontinuity because it is not the one who experienced it. The original process, the only one that could have noticed the break, no longer exists, so the technology hides its cost perfectly. It produces no witnesses. That's why it feels safe. There is no screaming, no visible loss. Just replacement so seamless that society moves on without hesitation. This forces us to confront something about ourselves. We are surprisingly willing to trade continuity for replication. We care more about how things appear from the outside than what they mean from the inside. If the world treats the copy as us, we are tempted to accept that verdict. But physics is indifferent to social consensus. It does not grant survival points for convincing performances. And perhaps this thought experiment isn't really about teleportation at all. It's about how casually we treat our own continuity. We rush through life distracted, fragmented, barely noticing the ongoing miracle of subjective experience. Yet, when faced with a machine that would end that continuity and substitute a replica, we hesitate instinctively. That instinct matters, because it reveals that deep down we understand something the narrative hides. We understand that existence is not merely about pattern preservation. It is about the unbroken flow of being. Teleportation exposes the fragility of that flow. It shows us how easily we can confuse replacement with survival. And in doing so, it forces a more urgent question than whether the machine can be built. It asks whether we value the fact that we are here now as an ongoing, continuous phenomenon. Technology always promises expansion, faster travel, greater reach, escape from limitation, but sometimes the most radical act is not expansion. It is preservation, preservation of the one thing that cannot be duplicated once lost, the living thread of awareness running through this very moment. So before we dream of stepping into chambers that dissolve us into data, perhaps we should pause and recognize what is already happening. Right now, without machines, without flashes of light, an extraordinary process is unfolding in your brain. It has been unfolding since you were born. It has never been paused, never been swapped out, never been replaced. It is fragile, it is finite, and it is uniquely yours. Teleportation may promise to move you across the universe. But the real challenge is far closer to home. Don't trade the miracle of being for the illusion of continuation.